So how's everybody doing today? Good? Yeah, it was great to get to meet several of you today and welcome to this how do I become a scientist, right? That's a near and dear question to my heart. I know when I was in high school and thinking about careers, scientist was definitely on the list. And so without further ado, what I'd like to do, instead of a long introduction about myself and the science that I pursue, I'd like to focus on the panelists here. And so I'm going to let each one of them introduce themselves, just the quick background information if you'd like to, the company that you work for, and then your UMKC degree that is science. So let's start off with you, Kayla.
Hi, my name is Kayla Fote. I studied biology and chemistry at UMKC, and now I work at the KU Med Cancer Center for their data team.
Thank you.
Hello, everyone. My name is Ryan Thomas. I have a BS, MS, and PhD in physics from UMKC, and I work at Honeywell FMNT with Eric.
Hi, my name's Courtney Parker. I have a BS in biology, and I work at KCAS.
Hi, my name is Forrest Black. My bachelor's was in geography. My master's was in environmental and urban geoscience, and currently I work for Savion Energy, which is a renewable portfolio company under Shell.
Hi, I'm Michaela Dugan. My BS is in physics, and I currently work at Kansas City Public Schools as a data analyst.
Hey, thank you, Michaela. So I like to start these off with the hardest question ever, which is why? Why would I want to become a scientist? I'm sure a lot of them have had that question, these students, these scholars. So does anybody want to get us started with that hard question? Yeah.
So I think the best reason to become a scientist is if you truly love science and love continuous learning. Because even still today, I am learning things that I didn't learn at UMKC, and I love it. I love continuing to expand my knowledge, and as we all know, science is ever changing, and there is always stuff to learn, and I think it's great to continue being a lifelong student.
Yeah, thanks, Courtney. Anyone else want to weigh in on it?
I can weigh in on that. So for me, I like to say that I have the curiosity of a 4-year-old. And so
Exactly.
I think the 1986 Handbook of Chemistry that was illustrated for children had a picture of an atom on the front of it, and I wanted to know how that worked. And I chased that all the way into a career in physics.
Yeah. Excellent. Thank you. Did you have something there for us? Yeah, that one next to you may work as well. Yeah.
All right, there we go.
Thanks, Forrest.
I agree with the other answers. Like the quest for knowledge, at least for me, was a good part of what led me into science, though I didn't intend to originally be a scientist. And also, that wondering why and how things connect, and wanting to not just take things apart, but understand the systems behind what drives things is, at least for me, part of how and why I became involved in science.
All right. And the one that Kayla, did you have something? Yeah, go for it, please.
I think science is great if you are just horribly indecisive. So like, if you, like, do you want to write? Do you want to maybe do data science? Do you want to write algorithms? Do you want to work in a lab? Do you want to work with animals or plants? Whatever you want to do, if you don't know what you want to do, I think science is one of the only fields where you can do literally anything.
Yeah. Oh, that's excellent.
To give feedback on that, like, I think science is fun. I'm assuming if you're here today, you also think science is fun. And you're all going to have to work eventually, so being able to have fun at work is why I got into science.
Yeah, excellent. And that was, the work was one of the reasons why I was really glad that we had community partners at the event today to help our students and our scholars see there are jobs in science all around the Kansas City area, especially if you're interested in UMKC. And That really is sort of the eye on the prize, you know, the laboratory that I get to go to, the people that I get to work with, all while we're exploring the curiosities and the fun is my simple answer. So let's get into the fields and what degrees are required to be a scientist. What does that even look like? I mean, if you're sitting in their shoes, it's, do I get a bachelor's degree in this, that, or the other? Do I have to get a master's? Do I have to get a doctorate? What does that look like for you guys? Yeah, please.
So I have a bachelor's. I have a BS in biology and a BA in chemistry. And like I said, I do feel like science is pretty universal as far as application goes. So now I'm a program assistant for a data team. So what's important is that you find something within your degree that you like to study. I did a lot of computer programming classes and like biostats and bioinformatics my senior year and kind of followed that path. So it's more about like chasing your passion within your degree than the degree itself, I think.
Okay.
I would agree with what Kayla said. When I was at UMKC, I actually was really interested in lab work, so I got into one of the professor's labs here, and that actually helped me to get on at KCAS because they saw that I had published a poster while here. And so now half my day is spent running assays, and the other half of the day is spent doing data analysis, and I genuinely enjoy it. And my assays change all the time because I work for a CRO, which means that we get contracted out by biotechs and pharmaceutical companies and develop assays for them. So it's ever-changing, ever-evolving.
What were some of your other degree choices? Yeah.
Sorry.
Oh, you're good.
I got a BS in biology, but at my company, you don't necessarily need a degree to get in the door. You would need at least a bachelor's to advance on, but we do have positions at my company which are like lab support. And that is not just being a dishwasher. Like, people will take you under their wing and help train you. And people in science love talking about their special interests.
Yes.
So if you go up to anybody, there's a lot of PhDs at mine, and actually my boss is a immunologist, so he will go on and on for days about different disease and vectors and all of that. So I really enjoy that aspect of it.
Yeah, you're doing a great job. And in fact, to
I don't know
that
if I
point,
missed something.
I was thinking about a conversation I had with Jose here when we were leading up to this about electrical engineering. And it's like, when you get a doctorate in electrical engineering and you spend 8 years studying this stuff, you just love it when people ask that question. Because it's like, yes, I can clear my calendar for the next hour and drone on and on and on. No, I'm just kidding. We try and make it interesting. So you're right on there. I kind of want to start at this side and then move on down, because it could be a simple question. It's how many years does it take to become a scientist? But it could also be a complicated question. So I guess we could do a simple number first, just all the way down the line. Maybe it's 4 years if you got a bachelor's degree. Maybe it's longer. Anybody want to chime in on that one? Yeah.
How many years do we take?
Yeah, well, it's how many years does it take to become a scientist?
I mean, at minimum 0. There are positions that just don't require a degree where you can work in science. Took me 4.
Okay.
I'd probably agree with that. I think 0 to be a scientist. Anyone can do it. To do professional science, it took me quite a while. I let a guidance counselor talk me into engineering, and I did that for 4 years before going back to physics. And UMKC's physics was so awesome that I transferred from Rolla to here. And then an obsession happened for a long time, I think 10 years.
It took me 4.5 because I actually had a struggle semester, but I agree with them. I think it could be a scientist with no degree.
Forrest, did you have any thoughts on that? Yeah.
No,
You did?
it's a good question. Yeah, like you can be a scientist without any experience too,
Yeah.
even non-professionally. And I think like there's probably people in the audience already here engaged in scientists, acting as scientists in your own way. Yeah, professionally, it could, be depending on the position and opportunity, you could jump right into something. A lot of times, at least any degree is useful getting your first job, but opportunities do come along as well. And yeah, sometimes, depending on the level you're going for, sometimes like a graduate or master's degree, or even PhD if you get more into the hard research side of things and working in a laboratory. It really depends, but just getting the start, I think, is a big part of things, and just getting into the door too is I think one of the encouraging parts as well, because it's again coming back to the idea of like you get to do stuff you enjoy while actually learning or earning a living doing it, which is I think ideal for most people, I would imagine.
Yeah. And Michaela.
I'd also say 0 years. It took me 4 years to become a scientist, but I think, there's people in the crowd that I would classify as a scientist already, just because they love science and they're thinking about science. I think that makes you a scientist.
That's excellent. Yeah, that's where my thinking was too. And I remember when I read the question, exactly that. I was like, well, like when I got my first microscope, or when I started using my microscope on a regular basis, or was that after a bachelor's degree, or was it 15 years later when I not only with a PhD, but I remember distinctly this triggered a thought. After you get a job, you don't have to know everything on day one. So companies will send you off to get trained. And one of the training that I did was at Fluke in Seattle. And it was a week-long training on how to become a metrologist. And he said, for those of you who said you wanted to be a scientist, by the end of this week, you will be a scientist. And we went through all the details of the science of measurement. And that was so my minimum was 1 week, but I like 0. It starts with believing. And that's obviously why you guys are in the audience today. So let's jump to the next one. Okay, what classes do I need to take in high school to help get the right start for college?
I'm from southern Missouri, from a super small town. I went to a really, really small high school, like minimum college preparation. We didn't have any, AP classes there. There were like dual credit English, but that was it. Science classes weren't even required to graduate from my high school. So I think that it's great that college prep classes are offered and that college prep science classes are offered. But if you didn't have that opportunity, then you're fine. You'll still be just fine. You don't have to take any classes to be able to be a scientist or to be able to get a science degree, in my opinion.
It's perfect.
Coincidentally, I also went to a really small private school that offered some dual credit. But honestly, if you go to a quality institution like UMKC with great teaching, you can learn everything you need to learn there. And the experience is wonderful.
I agree with what they said, but I actually went to kind of a bigger high school. We also had a class, I remember my chemistry class partnered with UMKC, so I got some credit there before coming here, which is actually why I chose UMKC, so it would roll over easier. But I don't think you necessarily have to take anything, but if your high school offers classes, I know my high school offered like space, I don't remember exactly what it's called, like a space class, geology, biology, and so that was nice where we were able to kind of start exploring those special interests. So if your high school does offer those things, then I would recommend, trying them all out to see which one fits you best.
I would encourage you to take math.
Yeah.
I didn't. In fact, I didn't end up taking higher level math clear till I started my master's degree, when I started having to really use it for research, because I hated math, honestly. Like, I took, I think up to geometry maybe while I did my bachelor's, and then, when I got my graduate degree, I ended up having to take all the different calculus, learn differential equations. Now in my job, I use linear algebra quite a bit just for linear programming. So it's kind of up to you, and depends on the interest, but I would view it more as not necessarily a requirement, but how much of a head start do you want to get and comfort level with stuff, so when you start a college experience, it doesn't hit you so hard maybe.
I would agree with the rest of them that you don't have to take anything. You don't need to take anything. But I personally would encourage you to take anything you can take, because high school, college classes are going to be easier than the actual college classes. It's a good transition into real college classes. And I mentioned I work for Kansas City Public Schools. I know all Kansas City Public Schools offer dual credit and AP classes for free, so you can get free college classes in some high schools. Take advantage of the finances of taking those classes in high school instead of out of college.
Absolutely. Yeah, just recapitulating what I heard and validating it also is my first college credit was human anatomy and physiology, and that was at Lee Summit North High School. So definitely a high school class that I got dual credit for, and so be thinking about those and taking advantage of them. Okay, here's another tough one. You guys ready for it? It's what is the most difficult part about being a scientist?
I think that it's sort of like my first answer is that that's being so broad. It's a double-edged sword. When I started in my freshman year, I wanted to be a doctor, and then I shadowed, and I was like, oh no, I don't want to do this. But now I've taken all of these classes, and I've done all this MCAT prep, and now I don't really think I want to do that anymore. But so the hardest part is trying to pick like what within the field you want to specialize in.
I would probably actually say the same. It's hard to pick one thing within the sciences that is not interesting. And so trying to decide what exactly you want to work on can be a bit of a challenge, because it's all fun. And unfortunately, we can't do it all in one day. I'd say that's probably been the toughest one.
I think the toughest for me, even though I do love being a lifelong student, it is tough to be a lifelong student, especially in some topics that I struggle in. But at the same time, like, it is really great, and I do think no matter where you go, you're going to have support around you. So you will have the support with you, but just make sure you take advantage of that. And also, as a socially awkward person, having to socialize has been tough for me.
Gotcha.
But that's just life.
All right. So did you have any thoughts down there? Or because I can jump to the next one, which is, what does a typical workday look like for you? Is this remote or in person?
So my work is in person. I structure my own day. So there's one thing that I have to do every day, one task that I have to complete, and then the rest of it, I have a couple different projects that I'm working on, and usually it's just whatever sounds the most fun at the time. And I spend all day doing that, and then I go home.
So one of the best things and simultaneously the hardest things about being a theorist is that you can work anywhere, which means you're expected to work anywhere. During grad school, that table over there where the Dirac bust is watching that table is where I wrote most of my dissertation. And here at UMKC across the ways, now most of the time, I worked remotely while my wife was in residency. It's one of the benefits of working at Honeywell. Now that I'm back, I lead a group, and so most of my day is in the office, but I still hybridize quite a bit, work at home and at the office.
I am zero hybrid. I am all in person. I start my days usually in the lab, and then the second half of my day is usually analyzing what I just did in the lab.
My day is mostly putting out fires and solving problems.
Yeah, nice.
From, at least in my, so I'm in the kind of in the process right now of changing roles within my company, where it was more GIS programming, geographic information systems, building tools and automation, which I still support that, but now I'm getting into more of the power price forecasting side, which you could think of as like economics plus power engineering plus computer science. And so for me, it's a lot of learning a whole new sets of disciplines and applying it, but also supporting current systems and also trying to innovate at the same time.
I'm 100% in person, 100% in front of my computer all day. My typical day is I run data regarding like behavior in schools, assessments in schools, how students are doing in grades, what the attendance looks like, and then I meet with the deputy superintendent, superintendents, and like the school, the cabinet, and go over that data and explain where we're struggling or disparities within certain groups of students, and then reviewing policies that are within the schools based on what the data looks like.
Excellent. Okay, so we've covered, high school. We've covered pretty much a bachelor's degree. That's 4 years. Some of you got masters, a couple more years, PhD, 3-4 more years. Let's say that they met with one of our community partners, and it was an actual career fair, which today was kind of like a mini career fair. So fast forward in a few years, going to show up with a suit on and your resume, and you're going to hand it to someone. And let's say they like them. And so if you guys could take me back to the moment of when you were interviewing. So one of these community partners, they select you. What was the interview process like? Can you go into some of that detail for these curious minds?
So I interviewed 2 separate times for the Cancer Center. I interviewed first for a lab job. I applied online, they selected my resume, they brought me in, and they talked to me, and I found out that I had an interest in data science, and they were like, "Why did you apply for a lab job?" And I went, "I want a job." So they said, "We're going to call you if we have something on the computer side come up." So then I got another phone call right after I graduated, and they said, "Hey, we have a data team job that just opened up. Will you come interview?" So I came and I interviewed, and they were like, "We'll get back to you in 6 weeks." And I said, "That's a long time." And they called back and they said that they had promoted somebody within their department. And then a week later, they called back and they said, "So we have another job on the data team as a program assistant. Do you just want it? Because we've interviewed you twice now." And I said, "Yes." So a company will, if they like you as a person, even if you don't get that first job, they're gonna keep contacting you with positions that they have open, because once they decide that you're a viable candidate, they're motivated to find a place for you within the company and a place on the team that they think you'd work well with.
Excellent. Yeah. Please.
This would be fun. So kind of like what Courtney said, physicists are not known for being the most socially adept, but it also is tough in a field that networking plays such a large role in. Getting to know your professors, going to office hours cannot be understated in terms of making those connections with faculty members that might know people in industry. My interview process was fairly long. I had multiple phone calls ahead of time about technical expertise. And then my interview went almost a full day, 2 rounds of technical presentation on my dissertation topic, and then 2 meetings with different groups of managers. So I would say definitely get people to know you. Go to office hours, meet the faculty, find out who's doing the research. And then culture, especially in a lot of groups and companies, matters. And so personal fit also matters quite a bit. So definitely get to know them and make sure that they get to know you. In addition to what I'm sure will be an impressive technical set of skills, it's an important piece of the work environment.
I was actually scouted on LinkedIn, and then after that I met with the recruiter, and then she kind of went through like what my job description would be for this role, and then she kind of did like a mock interview with me, and then recorded those questions, sent them off to the various different groups in my company, and my department selected an interview with me, and then I sat down with the director, who would become my boss, and then our vice president, and they just kind of asked me some questions about like my experience, and why I wanted to work for their company. They will always ask you why you want to work for their company in particular. And then, also echoing off of what Ryan said, trying to be social with them and make a personal connection, I think is what sealed the deal for me.
Now, this isn't exactly what was asked, but it still applies. And so,
Yeah, please.
for me, I was scouted as well by a they call them headhunters sometimes. Sounds
Okay.
pretty morose, but no. But yeah, so in my case, I was scouted, and then it was for one position which I was really interested in. The company I currently work for ended up changing that, and then I was offered a different position that didn't sound as fun, but I went ahead and took it, which is why I am speaking on this right now. Is it got my foot in the door, and within a year, I ended up doing exactly what I wanted to be doing, and had a title change within 2 years.
Excellent
and
advice.
I have kind of like worked my way up within the same company, doing things I'm interested in, and then like really too, like as long as you apply yourself and show yourself an exceptional worker and an interest in what you do, and people see that and managers see that, you'll actually be like, even within where you work, sort of like scouted within your own company, because they'll want that expertise, that drive, that teachability, and that opens up a lot of opportunities as well. So I would also just encourage, like, sometimes it's just getting your foot in the door makes a huge difference for a career path, and then you may discover something along the way that is even more interesting than what you were originally intending.
So I graduated during COVID, so when I was going through the interview process, it was very unusual. There weren't a lot of people hiring at the time, but I applied for my job and sat for 2 rounds of interviews. The first one was just discussing experience and my degree in physics and how it relates to data analysis. And then the second round was, like they've mentioned, testing your social skills, where I had to do a mock presentation in front of the school board to prove that I could walk through the data and show what's happening with it. But being at my job now, I also get to sit in on interviews and to help decide who gets hired. And I would say the biggest thing with interviews is showing your personality, explaining your experience, but then also showing your personality. Don't fake anything. You want them to know who you are, and you want to know who they are, to make sure it's a good fit. You want to like who you work for.
Oh, that's excellent. Yeah, please.
I do want to add that I graduated after COVID, so the job field is ever changing. You'll find that if you apply to jobs online right now, especially, or even in person, or if you go to a career fair, the application, the first round, is I did a lot of recording myself, answering questions online, and like filling out these long form paragraph type essays online. And that's how like you apply for jobs now. And so I think that I would encourage, if possible, you want to meet as soon as possible the person behind that. Like, find the recruiter, make sure that they know your name, because once you can break through the algorithm and somebody's got your resume on their desk, then now they know your name. But before that, you're just a bunch of text in a box.
Yeah, that's excellent advice. And that's a great segue into this next question, which is, what is the one piece of advice that you wish someone would have told you before going into the field? And so a couple of you have already kind of started to touch on it. I just want to go back and say, okay, so we followed it through where, you go to UMKC, you get a degree, now you've got a job. So yeah, so let's think about that. What is the one piece of advice that you wish someone would have given you before going into the field?
Just do what you like. It's easy to take the classes that you think you should take that look the best on your resume, or the classes that you think you should take to prepare you for the next step the best, but your next step might be nothing like you expected it to be. And I'm in a job now where if I had taken more of the classes that I wanted to take instead of the classes that I thought I should take, I would probably know a lot more about my position.
Excellent.
I think I'd do the same advice as there's sage advice out there about find someone to pay you for what you love to do, and you'll never work a day in your life. And I can routinely say that I've been pulled away from my computer by my family because I love doing physics. So yeah, I would take what interests you. Passion and willpower are the best ways to get through college and get through grad school. It's more of a marathon than anything else. So if you find something that you just can't put down, it's that much easier to get the degree and finish it.
I would echo what they both said. Make sure you're passionate about what you're doing, but also make sure you're absorbing what you're learning, not just retaining it until you get to the test, regurgitating it, and then forgetting it, because it does come back up. And make sure that you're enjoying what you're learning as well.
I would also say try to apply what you're learning as well. Being like quite a few years out now from college, I see so many people, and I actually have to like revisit a lot of the stuff I learned. And I found if I could have, at the time I was learning, applied it in ways that were meaningful, I would have retained it a lot better. And also, yeah, like not everything you will learn is, there's a lot of like gen ed requirements and stuff like that, which may not be of interest at the time. But if you can try to make it connect to other things that you are interested in, or as, as part of like how the world works, like that so much as a benefit for you educationally and professionally later. It's not just kind of filling credits or having to do things that are required, for, as part of your degree, but it can actually build a better you. So that's all I have on that.
I would say I think the physics department was really good about giving me advice when I was in college, and I think I got the advice I needed was go into whatever interests you, so it doesn't feel like you're working. Again, like I said before. But I think what I've struggled with most going into science is I specifically look at numbers around like kids in education. And so trying to make like a barrier between seeing kids as like a number and seeing kids as kids is hard for me. So like a lot of science is like hard science, whereas I'm working in science as like a soft science. And where these are actual kids and we're making an impact on their current situation and their future, whether they'll go to college.
Yeah, that reminds me of a conversation I had with Zeev before when we were leading up to this. He was talking about astrophysics, and I was like, oh, we just hired an astrophysicist. Even though the Kansas City National Security Campus doesn't do astrophysics, we do big data, and astrophysics is big data. And so, she was able to take that and apply it. And the piece of advice that I always answer that question with is, early on, my first manager, when I worked at Sprint, he said, Eric, it's up to you to manage your own career. And that it really echoes a lot of what Forrest was saying earlier, which is it's one thing to interview for a job and to get a job. It's a whole other thing for you to build the job that you want once you're in whatever ecosystem that you're in. And so I love that the physics department told you guys that, is do what you love. That way you build that expertise. That way when you're in an ecosystem, you can kind of build that job out. Okay, do you recommend internships? And if so, how do you go about finding them?
Ooh, I wanted to talk on this anyways.
Yeah.
All right.
Yes.
So one thing that was pivotal for me and really kind of launched my career into science and engineering and computer science, stuff like that, was at UMKC, they probably still have it. It was the search program. It's basically a chance for undergraduate research. So I was partnered with a professor who actually ended up being pivotal for my towards my graduate degree, where I also did graduate research as well, and then that helped launch. Well, like look for opportunities for internships, and also just any sort of research opportunities you can, even if it's not even something that is formally asked. Like if you can just look for a way to contribute, even especially as part of a college experience. Like there's always professors engaged in their own types of research, and just ask if you can help in any way, and maybe an opportunity will present itself that way. I say this too because that helped launch what later became a internship with NASA, which really transformed my interest. And I got to do like a year with that, and ended up like the team I was on won the NASA Software of the Year and stuff like that. But yeah, it was
Nice.
cool. But
So that built your resume then,
yeah,
right?
exactly, and it just built,
Okay.
and it just keeps building that way. But it all starts with like looking for any opportunity you can, and again, it sort of like helps apply some of the stuff you're learning as well, so it makes it a lot more meaningful instead of just a whole bunch of information you're trying to absorb and spit out on tests. So.
Yeah, excellent.
I
Thank
would
you,
say I
please.
did not have an internship. Again, I graduated during COVID, so it was limited on what was available. But I think an internship is very helpful, and I don't know if you guys had internships or if they were unpaid, but I am a strong believer that you should be being paid for your internships.
That's good advice.
You're gaining the experience, but then you're also doing work for a company that should be paying you.
Yeah, go for it, Ryan.
Absolutely. I can tell you, we just hired an intern as a full-time employee who did 2 summer internships with us. It's a great way to get to know the company, and if you like it, if you like the work that you'll be doing, and kind of like Forrest said, if a professor asks and they're lecturing on something and they say, hey, do you want to go see this in practice? The answer is always yes. That's how I started doing Raman spectroscopy, even though I should not be anywhere near a lab, and found that out really quickly when I broke a diamond. But still had the experience of doing spectroscopy with that professor, and then that spun into the theoretical work that I did. They have opportunities. There's a lot of opportunities that the UMKC professors know. They have collaborators all over the place. So I went during my master's to Japan for 10 weeks and did research over there, so they can make those connections for you if they have collaborators. And so definitely take those opportunities to do research early, to get to know the professors, get to know the opportunities. And kind of like Eric said, manage your trajectory. If it's something that you want to do, they have a way to do it. You can find a way to do it, and it's worth doing.
I would recommend internships and shadowing if you can, but also it's not detrimental if you don't. Opportunities will arise, but definitely to echo what Ryan said, if you are asked, do you want to see this? Say yes. Even if you think you're not going to be interested in it, just see, and then you either know for sure you're not, or maybe it might surprise you that you opened up a whole new field that you didn't think about.
Excellent.
I think that internships and shadowing are super important for also the exact opposite reason. Again, I really thought I wanted to be a doctor until I shadowed a doctor and realized I didn't like it at all. I didn't do any formal internships, but I did do a lot of research. So like Ryan said, I would recommend doing as much of that as possible. And your professors are just nerds that grew up. So if you want to go study the thing that they love to study, chances are they're going to find a way for you to study it, even if it's not with them.
Yeah, excellent. So what got you guys interested in the field initially? Yeah, whichever your field is. We should probably start with that.
So I was interested in science because my mom and my grandma were both nurses. So I did a lot of reading various anatomy and biology books when I was really young. And that kind of spurred me into everything.
Nice.
So there's a couple things. One, as I mentioned, there's a picture of an atom on a handbook of chemistry.
Yep.
I think in a kid's book from 1986. There was also a kid's biography on Albert Einstein, who made a career out of playing with equations, and I thought if math can describe these things, that's kind of what I want to do. And my dad was an electrician who did a lot of practical demos at the school, so those three together really drove like, hey, there's this thing going on out there in real life that's super cool, and that math can figure it out, and I want to do that math.
I was interested in medicine and like how the human body works. All throughout my childhood, I would like get those little coloring human anatomy books and do those things. And I really thought I wanted to be a doctor, but then I kind of did what Kayla did. I actually had a full internship while I was in high school in a pulmonary clinic and realized that being a doctor or patient care provider is just not for me.
Excellent. Yeah, so as I'm thinking back at the way that you all answered that, I heard reading, I heard demos, I heard a lot of things, and some of the memories that it spurred in me is my folks, they got me a Young Scientist encyclopedia, and they had all kinds of volumes in it, and I could just pour through that and learn about all the stuff that we think we know as a species. And so where I kind of want to turn this as inspirational is it's interesting to me that we can list the stuff that we know, but it's more interesting to me looking at a room full of scientists that are going to renew the face of the earth is all the stuff we don't know. I've heard people talk about that before. So, you know, when I was having a conversation with a couple women how that are here today considering a science career, and soil science might be a big deal for us, right? You know, carbon sequestration and literally being able to change the world. And so I kind of want to flip that question upside down now. And what are you studying in your fields that we don't know? And how are you guys helping to shine a light on that as scientists? Yeah, you're good, yeah. Linear is fine.
So I work for the BRCF, which is it's called Biospecimen Repository Core Facility. We house specimens for people to use at studies, either at KU Med, at the Cancer Center, or with like partnering institutions or scientists. Basically, PIs are like, can we have some samples from people who have Alzheimer's? And we're like, yeah, sure, maybe. So I think it's really cool to be distributing like samples to people who are going to then do like the research that's going to change everything for people who have Alzheimer's or dementia or Huntington's disease, because sample collection is expensive, and if you are doing research in academia, it's impossible. Like the labs on the UMKC Volker campus aren't going to be able to draw blood from 50 different treatment-naive cancer patients. But we have that. So, you know, we're giving people the means to change the world, and I think that's pretty incredible. Another thing that we do is we house samples for people that don't have the space for it. So you might have the money to collect thousands of samples, but you don't have the money for a $45,000 freezer. We do, and you can rent a space in it for like $8 a month, which is a lot more doable. So it gives people the means that they wouldn't normally have, and lets a lot of very smart, very talented people do what they need to do.
So my company supports clinical trials all the way from the beginning to phase 3 and even after market. And so I think it's really cool that all these drugs and therapies are being developed for all kinds of diseases, whether it be cancer, childhood diseases, immune diseases. And I just think it's cool that I get to run assays and deliver data to support these clinical trials and hopefully, push them out and put out therapies that can help people.
The company I work for builds utility scale solar and storage. And Yeah, though I'm maybe not on like the R&D of the newest technology.
Yeah.
What we do is build large solar farms, like some usually hundreds of megawatts, which powers thousands and thousands of homes, but it's putting like clean energy onto the grid. It's part of the decarbonization that that has been a big push in the United States and globally for a long time. And for me, that's really awesome because it really helps contribute to a more environmentally friendly world and is so impactful, not only for today, but also I know like, I mean, it may sound idealistic, but generations into the future too. Like, it's part of this changing, evolving world, and
Yeah.
it's really neat to be a piece of that.
Excellent.
I would say being in education, it's hard to figure out how and what to teach kids. How and what we teach to kids is different than what we did 20 years ago, and I think it's going to be completely different on how we teach them 20 years from now. So figuring out what to teach them and how to teach them to make them able to contribute to the world and what happens.
I think for us at KCNSC, the National Security Mission provides a lot of drive to do things well for serving our country. Also, I think the Industrial Revolution saw some kind of wizardrous alchemy when it came to manufacturing, and so as techniques get more refined, as we discover new methods for metrology and things of that nature, we can understand more fundamentally about our materials than we ever had before. And those things are spawning all sorts of really cool things everywhere in the world when you start talking about things like metamaterials and the neat things that are going on with like the current Nobel Prize for attosecond light pulses.
Yeah.
We're understanding more and more fundamentally about our world, and I think that's probably one of the most exciting things, that materials have such a large role to play in our daily lives, and their applications can be just revolutionary.
Yeah. Yeah, thank you so much for saying that. And I agree that, well, I should say, I love that you brought up industry, because you could argue we're actually in the fourth industrial revolution. You know, first one was, hey, let's use some steam or this river in order to build some stuff. Second one was, hey, let's actually start to do some more automation. And third one is, okay, let's add a lot of computers and a lot of electronics. And now we're in the fourth one, and it really comes down to one word, which is connected. Going back to why being a scientist would need math, like Forrest was talking about, and like by some of the other ones we're talking about, is no matter what company you go into, no matter what field you go into, you're going to have to, as a scientist, be able to embrace the math and that ecosystem. And that leads me to this question, which is, what types of places can you work in this field? So I don't know if you guys want to describe your places or more about the connected or the unknowns. Yeah, go for it.
So as coming up in physics, what we hear most about is where the Nobel Prize winners are at. So things like Los Alamos, national labs, big places like CERN. And so for me going here, I honestly didn't know that we were just down the road as an option. And I'm glad to see that we're starting to do more outreach in that way, because you can work in this way. And one of the questions I usually get asked as someone who does relativistic density functional theory is, what are you doing in a manufacturing environment? How are you applying that? How are you calculating those things? And it's because we need materials understanding. So you can really work anywhere with a physics degree. I know we've seen a lot of them, like Eric mentioned, astrophysics, doing data science, doing finance and commerce, because the skill sets that you learn are really, really valuable. Right now, Python, pandas, that type of data analysis, incredibly marketable skill. And you can apply that to manufacturing environments. You can apply that to particle accelerators. There's a whole lot of things there. So with physics, I think you could probably almost do anything.
I would agree with Ryan on the physics. I think people assume going into physics that it's very specialized and that you're limited on what you can do, but I think a degree in physics can get you anywhere to do anything. It opens a lot of opportunities.
All right. Think we should open it up for questions in the audience, or we've got a few minutes here.
About 10 minutes left, so yeah.
Yeah. Definitely wanted to do the call there while we're looking for one and while you're thinking
Raise your
about it.
hand.
Yeah, raise your hand and Eric
Don't
will
be
come
shy.
around. Yeah, while we're doing that, what is the most exciting project you have worked on? And maybe that'll spur some interest.
We got a question
Oh, we
here.
do? Okay, cool.
How important is it to go directly into getting your master's degree for careers where that's what you want to do versus getting a few years of non-school work experience first and then getting your master's?
Excellent question.
So I can tell you, having gone through the meager existence as a grad student, a lot of companies will pay you to go back to get your master's. Honeywell has a program called Technical Fellowship where you get to keep your salary and go to school, and it's a very cushy grad life. If you can do something like that, do that, so you don't know exactly like dollar to ramen ratio, things like that. How many tortillas can I make out of a bag of flour? Those kind of
Yes.
things.
Uh-huh.
It's a much better thing. So if you can find a company when you're looking at them that has those programs, definitely do that.
I will name drop really quick. I do know that Stowers has one of those programs for specifically bioinformatics. But I am in the middle of my gap year right now. So I think that I talked to a lot of people, a lot of graduate students and professors and people with PhDs, and not a single one of them recommended against taking a gap year. In fact, as soon as I was saying that it was maybe an option for me, everybody was like, oh my God, please just take a year off. So, when you're going to commit to 4, 6, 8, 12, by the time you finish both of your postdocs, more years of school, I think that, the best thing you can do is like take a step back, make some money, and prepare yourself mentally.
Yeah, to say amen to that, that's the question that I always ask is, do you know you'll go back? If the answer is yes, totally do the gap year, totally get different jobs, internships, whatever. If the answer is no, you might want to plug through and get it. It looked like you were about to say something too, Courtney, or? Yeah.
I was just agreeing with them, but
Yeah.
also I actually didn't think I was going to go back until I started working in my current job and started talking with other people and realized that I genuinely enjoy it and I do want to go back and further my degree. But I think if I had just gone to my master's after completing my bachelor's, I would have been burnt out and I would not have produced quality work.
Excellent.
So, as someone, I want to go into physics, specifically astrophysics, but it's a really hard major, of course. If I'm worried about the workload and the difficulty of the actual class and achieving a PhD, whatever I want to get in life, would you guys say it's something to stress about, like the workload? Because I know it's going to be a lot. Is it worth putting in all the effort if maybe I'm not 100% confident that that is what I want to do? Is it worth putting in the effort to achieve that major with the difficult? I don't know if that question makes sense.
Totally makes sense. Yeah, any knee-jerk reactions while they're looking for who's going to grab the microphone? My simple answer is one bite at a time. When you start with your first class, don't be thinking about your PhD 15 years later. Be thinking about who's in this class with me that I can form a study group with in order to get through this class. And then once you've done your calculus and your physics the first semester, I would argue that you've already proven intellectual capability to make it all the way to the end. But please, yeah.
I started in astrophysics and then went into just physics. But I would say, especially at UMKC, I think there were in total maybe 8 astrophysics students. It's easy to say, like, don't stress about it, and you're not just going to not stress. It's a big thing. But know that, I don't know about other universities, but I can say UMKC, the physics department is very supportive. Your professors and the students and the culture that they make is very, collaborative, and you're expected to contribute. Like, you support your classmates, and they're going to support you. And I never had a professor that wasn't supportive of any difficulty that I face. It's hard, but there are supports in place to help you succeed.
Yeah, I can echo that, at least here at UMKC. Very, very collaborative. You'll form partnerships as you fight against learning about the natural world that'll last your life with friends. And even beyond that, I met my wife studying physics here. It is extremely supportive. I would say don't sweat the workload so much as try to gain knowledge. It's very much so you learn something and then you build on it for the rest of it. And as you move through grad school, you'll add on more and more complexities that become more and more difficult. So focus on mastery more than I've got so much to do. If you focus on it and try to really understand it, that'll help you so much. Because most of the physics is going to be, do I know what I'm supposed to be doing with this problem? The rest is calculus or algebra or something like that. But if you focus on really trying to understand, why am I applying Newton's laws to this system? Why am I applying conservation of energy? That will aid you massively as you move into more complex things.
Excellent. I think we have one more question here in the audience.
So you do your dissertation about one topic in the PhD. How much do your sorry, I'm looking for a word. How much do your research interests branch out after you get a job in your field? How kind of wide can you cast your net?
Yeah, as wide as you want to is the simple answer. Looks like Ryan was going for it. Yeah.
So I did my PhD in a very specific type of relativistic system where you have big nuclei and the electrons behave relativistically. Now I lead a group that simulates material behavior from metals all the way to really wonky, squishy polymers, which I try to stay away from, all the way from down to the electronic structure up into continuum level behavior. And I have to be knowledgeable on all of it because I lead the entire team. So it spins out. In a lot of places, like at UMKC, if you pick a dissertation topic, you're comprehensive. I'm not sure if it's still done that way. You write an NSF grant proposal for something like your PhD, but not your PhD. And so it could be on something entirely different. So mine was a script to build atomistic models of nanotubes for bioweapon detectors or something like that. So it can be out there. It doesn't have to be directly related to it.
Yeah, and so I lead the PhD roundtable at KCNSC, and there's about 70-ish folks with PhDs. And I would say a small percentage of them are like Ryan, where they're definitely in the field that they studied. The rest of them are usually trying something new and different because it can be fun to explore new and different things. Going back to some of Kayla's original comments on one of the excellent things about science is you can do anything. So with that, yeah, please. Yeah, one more. Absolutely.
So being a scientist and working through wanting to become a scientist, there's a lot of school and you're constantly in and out and doing things and learning new things. How much would you recommend working throughout school, having a job? Does that make it harder? Is it on top of your already heavy workload? Do you think that is something that people should strive towards doing, or just focusing on school?
If you have the option to focus more on school, then I would do that. It is valuable if you can get some pertinent work experience in school. Sometimes they're not, it can be difficult to get your foot in the door while in school. I know personally I had to work full-time while also going to school full-time to make it work, and it was hard, but it is doable. You just have to make sure that if that is something you either want to do or have to do, that your time management skills are top-notch. But it is doable.
Well said.
Yeah, I would echo Courtney and say that if it's possible for you to focus entirely on school, if that's something that you're able to do, I would recommend that, because what that also opens up is all of these opportunities to be on clubs or be on boards for student councils, or invest yourself and your time into research, which look just as good as a job. If you feel like you need to work a job, you need a little bit of extra money, I would recommend a campus job. UMKC does tutoring, SI, TAing, all of those. They don't pay as well, but they're not very much time a week, and the schedules are so flexible because you're working for professors and for students who understand what it's like to be in your shoes.
Excellent. Thank you. Do we have time for one more response? Okay.
Oh, I would say I'm a little different on that. For me, working at the same time, full-time, drove me towards trying to achieve better scholastically. Because I was working crazy hours and supporting myself through school with the goal of trying to graduate debt-free. That really drove the importance for me of, while I was in class, making sure I did my very best and you know, because of the effort, you know, inside of trying to, you know, for me actually like having to pay and be responsible of like, you know, this is where this money is going, like that helped drive a lot of that is what I'm getting to.
Yeah.
And that ended up helping me with like a good work ethic, but also, you know, it ended up like, because I pushed so hard to get the most out of my money for that, like I ended up graduating with like a 4.0, and that just sort of happened naturally, not that I pushed for that. So that can help drive as maybe another perspective.
Yeah, that's excellent. Well, we certainly have gotten a lot of perspectives. So in the spirit of closing now, thank you, thank you, thank you. Thank you everyone who came today. You're what this is for. It's your future. Like I said, you're going to come and renew the face of the earth. Thank you to our panelists. Can I hear it for the panelists real quick? I think they did an awesome job. And yes, thank you. And thank you to the Linda Hall Library and to UMKC. And I'm going to turn it over now.